Hello everyone, I am Titus and I am from Christ the King Engineering College, Karamade. I am doing my degree in Electrical and Electronic Engineering. And today I am going to speak about the topic of slip power recovery schemes for induction motor. Now I am going to say about the basic principle of slip power recovery. The basic principle of slip power recovery is to connect an external source of the EMF of the slip frequency of the rotor circuit. Now I am going to explain about the static Kramer drive. The static Kramer drive only allows operation at subsynchronous speed. This is the basic circuit configuration of the static Kramer drive. The static Kramer array consists of a slipping induction motor. It is to be controlled a transformer and combination of the diode rectifier and inverter. Induction motor is fed from three-phase power supply. The input power is converted to mechanical power and the remaining power which is not converted to mechanical power is available in the rotor circuit. So they will feed the rotor power or the slip power back to the supply. We are using this setup because since the setup power has frequency which is different from the supply mains frequency, it cannot to feed back to the source directly. For example, the supply mains frequency 60 Hz. So the rotor frequency will be different from the supply frequency. Not a frequency is equal to slip. We have to change the wave frequency of the slip power and then it can be fed back to the supply. For the purpose, we are using this converter. Here, the slip power is to given to the diode rectifier which converts to slip power to DC. The receiving voltage of the diode rectifier is VD and this is an inductor. The inductor LD filters the ripples present in a DC voltage VD. This DC voltage is then converted to AC voltage at the line frequency using a line commutated inverter and pumped back at the AC source. This drive offers a constant torque operation. This rotor voltage is rectified by diode rectifier. For alpha is equal to 1, slip S is equal to minus cos alpha. For alpha is equal to 90 degree, then slip S is equal to 0, which is synchronous speed. For alpha is equal to 180 degree, then slip S is equal to 1, which is 0 speed. The motor speed can be varied from the 0 speed to synchronous speed when the firing angle alpha of line commutated inverter is varied from 180 degree to 90 degree. In actual practice, the rotor voltage will be less than the supply voltage. Hence, the transformer is omega required to step up the voltage before feeding T back to supply. Let the transformer turns ratio be alpha T is equal to V2 by V1. The three-phase terminals of the inverter is given to transformer. Inverter will be operating at the frequency which is equal to the supply mains frequency. So this inverter will be converting the frequency of slip power to the supply mains. So the supply main frequency, these are the conclusion or portion of the rotor AC power is converted to DC of the rotor AC. Power is converted to DC by a diode bridge that control rectifier working as an inverter converts it to the AC and it feedback to an AC source operation. Next, I am going to explain about static Kirby's drive. In static Kramer drive, the speed of slipping induction motor can be controlled below synchronous speed only. For controlling the speed below and above synchronous speed, the static Kirby's drive is used. There are two configurations of this drive. They are DC link Kirby's drive and Cyclo Converter Kirby's drive. Now I am going to say about DC link Kirby's drive. For controlling the speeds below the synchronous speed, the slip power is removed from the rotor circuit and it fed back into the input AC supply. For controlling the speeds above synchronous speed, an additional power is fed into the rotor circuit at slip frequency. It has a slip ring induction motor, two control converters and a smoothing inductor and a transformer. Smoothing inductor is used to suppress the ripples present in the DC link. Now I am going to say about subsynchronous speed control. Bridge 1 is operated with the firing angle range of 0 degree to 90 degree. It means that the bridge 1 works as rectifier. Bridge 2 is operated with the firing angle range of 90 degree to 180 degree. It means that the bridge 2 works as inverter. Now the slip power flows from the rotor circuit to the supply through the bridge 1 and bridge 2 and transformer. The transformer steps up the rotor voltage to the level of an AC input supply. Super synchronous speed control. Bridge 1 is operated with firing angle range of 90 degree to 190 degree. It means that bridge 1 works as inverter. Bridge 2 is operated with firing angle range of 0 degree to 90 degree. It means that bridge 2 works as rectifier. The slip power flows from the input AC supply to the rotor circuit through the transformer bridge 2 and bridge 1. The transformer steps down and the input AC supply to the level of the rotor voltage.
Rotor voltages at the slip frequency are used to commute the thyristors present in the converters. At low speeds, the voltage across rotor will be less and it may not be sufficient to naturally commute the thyristors. This difference can be overcome by using forced commutation. It means that an additional forced commutation circuitry is necessary for Scurbius drive, where both below and above synchronous speed are possible. Also, Scurbius scheme requires 6 thyristor in place of 6 diode present in a Kramer drive. Hence, the drive becomes costly compared to the static Kramer drive.
Now I am going to say about Cyclo Converter Scurbius drive. A 3-phase Cyclo Converter can be used to control a speed of 3-phase induction motor. Cyclo Converter fed induction motor are used in applications such as high power pumps and blower type drives. Using a Cyclo Converter, it is possible to send power in both the directions, and hence speed control can below and above synchronous speed is possible. Also, it allows regenerative barking, during which the power is fed back to the supply. Link DC Scurbius drive. The scheme also offers to constant torque operation. Subsynchronous motoring. This mode is similar to the static Kramer system. The state input or air gap power PG is positive and remain constant, and the slip power SPG, which is proportional to slip, return back to the line through Cyclo Converter. Therefore, the line supplies the net mechanical power PM is equal to 1 minus SPG consumed by the shaft. Super synchronous motor. In this mode, the shaft speed increased beyond the synchronous speed, the slip becomes negative, and the slip power is absorbed by the rotor. The slip power SPG supplement the air gap power PG for the total mechanical power output 1 plus SPG. Thank you and have a nice day.